And now we are on lesson 3, which was about end behavior. Okay? Oh, am I in the wrong? Yes, I'm in. There we go. Doesn't really matter, but. Okay, so end behavior. This was just a little fun thing to get you started. Okay, so we start with what we already were just doing. We're looking at this function. We're like, okay, where does it start? Where does it end? Starts at the top, ends at the top. But then we asked ourselves, how can we write that in math notation? And it turns out, this is how, right here. And this might be where you were like, wish there was a teacher, because I don't know what that's saying, right? So this is where I tell you what it's saying. Okay? Think about what this is writing here. It's saying, as x goes to negative infinity, y goes to positive infinity.
Wait, we don't have that. I don't have that one. Is it this one?
Yep, it's that one.
I don't have that one.
If you're missing one, they're all over here. So it should be a couple back in that. Okay. Yeah.
You have to put as.
Yes.
Points if you didn't.
I probably wouldn't take out points, but you do want to put as. Okay, so now I want to talk about what this means, and I'll give you a second to grab your papers. As x goes to negative infinity, what is that saying? As y goes to positive, what is that saying? Okay? So, I'll give you a minute. All right, so let's take a look at this graph, right? Remember, it said as x goes to negative infinity, y goes to positive infinity. Okay, so if I'm at the center of this graph, right here, and we're talking about x, which way is negative infinity? X.
Oh, that.
So as x goes to negative infinity, and then y is up and down, where does y go, up or down? It goes to positive infinity. So that's what that means. As x goes to negative infinity, y goes to positive infinity. Question?
We're always going to start at 0, 0.
When you're finding end behavior, yes.
Okay.
Yep. Now, what about the other way? Because underneath that it said, as x goes to positive infinity, y goes to positive infinity. Okay. So, starting at the middle, as x goes to positive infinity, where does y go? To positive infinity, which is why we write that. As x goes to positive infinity, y goes to positive infinity. Okay? It's basically saying, as you go left, you go up. As you go right, you go up. But we use expressions that are more mathematically academic. Okay? Let's do another one. In fact, this one, we won't look at the answer yet, and maybe you have it on your paper. So if I'm looking at this one, right? First I say, as x goes to what? Negative infinity. Where does y go? To negative infinity, right? It goes down, right? And then as x goes to positive infinity, y goes to positive infinity. So then I look at my my answer. As x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. Does that make sense?
Yeah.
Okay. Do we need to see another example? Okay. Here we go. Start at the middle, right? Remember, the question will be, I'll just give you an equation, and I'll say, give me its end behavior. And I'm going to expect the notation. Right? You can write it in words first to help you, and then translate them to end behavior. Or you can just draw yourself a sketch, right? Maybe your sketch looks like this, and then you think to yourself, okay, what do I say?
As x goes to negative infinity, y goes to positive infinity.
Right. Okay?
As x goes positive infinity, y goes negative infinity.
Perfect. Right? And that's essentially you're saying starts at the top, ends at the bottom. As x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to negative infinity. Okay? As you go left, you go up. As you go right, you go down. Okay? That's end behavior. That's how you write it. And like I said, you're probably going to get a problem that says, y equals negative 3x to the third plus 2x squared minus 10x plus 24. I don't know. And then it just says, describe the end behavior using math notation. Okay? So how could you do this? Well, you don't have a graph. This is where last lesson comes in, right? What's my degree? Odd. Is it reflected?
Yes.
So it's going to behave like a negative line. Where do negative lines go?
And it goes from top to bottom.
Down like this, right? Right? And that's kind of enough, but we know it's cubic, so let's do a little bit more. Here's what it's going to look like, right? And I can even add a little to help me, right? Now I can see where my middle is, right? Okay. As x goes to, this goes to, yeah, so I would say as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to, yep. So as x goes to positive infinity, y goes to negative infinity. And you've answered the question using math notation. Does that make sense? Okay. All right. Any other questions on this before we move on? Yeah.
Just a quick, I just want clarification. So if the exponent, that's our degree, but then if it's even, it's an even graph, and if it's odd, it's an odd graph?
Exactly. So if you got like x to the 12th, you won't, but you would know it's even. So it's going to be this or this. If it's negative, it's this. If it's positive, it's this.
Thank you so much.
Yeah, no problem. Okay? All right, moving on.